Hello everyone, it's time for another law of exponents example. Today we are looking at this example where we have variables in our exponents and where I'm hoping we can notice that at the top of the fraction we are multiplying, and because we have a fraction that means that we are dividing. Now guys, whenever we are multiplying and dividing, we are going to look at two laws of exponents. First, the multiplication law, which states that if you have the same bases, then you keep that same base in your answer and you add the exponents. And secondly, we're going to look at the division law, which says that if you have the same bases, you are dividing. Once again, you keep that base, but you take the first exponent minus the second exponent. Now, at the moment, we don't have any bases that are the same. We have a base of 4, a base of 3, and a base of 12. So what we are going to do is we are going to have to rewrite the bases of all our powers so that we can get the same bases. Now, the easiest way to do that is to use prime factor bases. Sometimes you can work with numbers that are bigger than prime factors, but I find that it's just a nice method to always find prime factor bases. Often that is the way to go, and that's how you will get the correct answer. So what I mean by that is that 4 is the same as 2 to the power of 2. 2 is a prime factor of 4, right? So I'm rewriting 4 as 2 squared. Now I must remember that that was raised to the power of x plus 1. And then I'm multiplying that by 3 to the power of x minus 1. Now 3 is already a prime number, so I'm not going to rewrite that base as anything else. At the bottom of this fraction, we have the number 12. Now 12 we know is the same as 4 times 3, and 4 can be written as 2 squared. So instead of 12, I'm going to write 2 squared times 3. There is a way of doing this on your calculator. I have posted a video on my TikTok about how to get the prime factorization on your calculator, so go look at that if you want to know. But 12, we can write that as 2 squared times 3. Now next up, we need to now actually multiply all of these exponents. So if we're looking at that first 2, we have to take the exponent of 2 and multiply it by x and by the 1. Next up, we're going to have our 3 to the x minus 1. And now at the bottom, we need to do that same process that we did in the numerator, but with the 2 and the 3. So again, the 2, our exponent of 2 is going to be multiplied by the x and by the negative 2. So that's how I'm getting 2x minus 4. And now for our base of 3, that exponent is 1. So if I multiply 1 by x, I'm going to get x again, and 1 by negative 2 is negative 2. Now I'm hoping we can recognize that we have two bases of 2 here, and I am dividing them. So what do we do when we divide and we have the same bases? I'm looking at this rule over here. We keep that same base, so we're going to keep our base of 2. And what do we do with the exponents? We take the first exponent, the exponent at the top, 2x plus 2, and we subtract the second exponent, which now, very importantly, consists of 2 terms. In order to subtract more than one term, you have to put both of those terms in brackets. That is very important. Okay, so we've sorted out the 2's. We're going to simplify that exponent just now. Next up, we also have 2 bases of 3. So we are going to put a times there because we are multiplying these answers together. We're going to keep that base of 3. We're going to take the top exponent, x minus 1. We're going to subtract the entire second exponent by putting brackets around it. Now we are going to simplify. You can skip this multiplication step. I'm going to multiply my brackets out. So I'm multiplying negative 1 into both of those brackets. This is a step that you are able to skip. If you can just kind of do it in your head, that's perfectly fine. But next up, we can see that if we have a 2x and a minus 2x, those two cancel each other out. I'm left with 2 to the power of 2 plus 4. So that is 2 to the power of 6. If I'm looking at my 3, I have an x and then minus x. I am left with 3 to the power of negative 1 plus 2, which is 1. So I am left with 2 to the power of 6 times 3, which is 192.